Great. I'm David Fouhey, and before I begin, I want to thank, like everyone, I want to thank Sarah for organizing this. This is really fabulous. It's wonderful. It's great to see the energy and enthusiasm in this space. So I'm an assistant professor at NYU in New York, and my lab really focuses on three main areas. So I originally was a 3D reconstruction person. I then got super interested in hands, and now recently in the past sort of 5 or so years, I've gotten very interested in how do we take the lessons learned from computer vision and help empower scientists in other fields to get good stuff. And so I've been mainly focusing on how do we get AI systems to generate data that scientists then turn around and use for discovery. And so what I've been trying to do is mainly take the lessons I've learned in my other areas and then bring them to new areas like ecology and physics. So next slide, please. So in the interest of time, I'll just talk about one of the projects that we're working on. And one of this is basically, it's the problem of the fact that there are hundreds of thousands of specimens collected over generations in museums that are basically just unmeasured. And this is a specimen of a ruby-crowned tanager from the University of Michigan Museum. And Michigan has a collection that has that's been collected over sort of a century, and it's this amazing contribution to science. And the catch is that it's not measured because each data point that you'd want takes about 15 to 30 minutes to measure, and you need training to be able to identify which bone you're actually measuring. And so 1 year's worth of effort would get you about 4,000 to 8,000 specimens, which is very nice, but which is certainly not the scales that a lot of people would love. And so the impact is that there's not enough data to test sort of very interesting hypotheses well. And there's this massive amounts of data, and it's a huge problem. So next slide, please. But along with Brian Weeks, who's at the University of Michigan, where I previously was before I moved to New York, we developed a system that basically can scan stuff extremely quickly. It's about a minute. The process can be done by a non-expert, and it's extremely safe, which is important because these are specimens that will be preserved and kept on for the next generation as well. And we can get measurement of sort of specimens, these are skeletal specimens, down to about a millimeter, which is sort of close to what experts can do. And this was accomplished through, as you've heard from lots of other people, this careful co-design of understanding what the ecologists want, what the AI can do, and sort of thinking about the whole process. And so we're currently ongoing. So we're hoping to get data from it actually later this week. We have a new system that we're hoping to use to scale up and do things in 3D and do lots of really exciting results. So if we have another one next year, I hope we'll have some amazing videos and reconstructions to show you. Next slide, please. And just in the interest of time, I'll just mention that doing a PhD in New York is great. It's fully funded in CS. There's limited TAing like many of these other things. And you also get to live in New York City, which is either really wonderful if you love New York, or it's really awful. And but you get to come to a visit to figure out whether you'd like it or not. So with that, I think I'm at 3 minutes, and I'll turn it over to the next person.